Example 2. The Brayton cycle. This question states that a simple Brayton cycle uses helium as the working fluid. Operating with 83 kPa and 15 degrees Celsius at the compressor inlet, has a pressure ratio of 14 and a maximum cycle temperature of 700 degrees Celsius. How much power will the cycle produce when the rate which the helium is circulated about the cycle is 50 kg per minute, assuming the isentropic efficiency at the compressor is 95%. This question is quite similar with the previous example. Please have a look and try to understand the previous example before you are doing this example. I will focus more on this statement. Assuming the isentropic efficiency at the compressor is 95%, it means that despite we are having an isentropic compression for the process 1 to 2, the actual outcome by the compression process will be the state 2A. Therefore, we are going to continue our discussion with respect to the previous example on to find the temperature at state 2A and find the power net out for this actual cycle. We know that power net out is given by power out minus power in. Power out is equal to H3 minus H4 with respect to the diagram that we have drawn previously, and for gases we can find the power out is equal to the mass flow rate times Cp times T3 minus T4. Meanwhile, to determine the power in, it will be equal to the mass flow rate times with Cp times with the temperature at state 2A minus with temperature at state 1. Since we know that in order for us to solve the power net out, we need to find the temperature for each state. For state 1, the temperature is already been given by the question. T1 is equal to 288 Kelvin. In order for us to find the temperature at state 2, we are going to use the isentropic relation for the temperature and pressure. Note that the values for the properties that we get by using the isentropic relation is the value for the ideal case. Therefore, we are going to assign the symbol S to the properties. We know that the isentropic efficiency for the compressor is given by the ratio of the isentropic value over the actual value, and it is given by this expression. For a gas substance, we can find the enthalpy by using these equations. From this expression, we can cancel out the terms Cp. Since we know the value for the isentropic efficiency for the compressor is 0.95, and we have the value for the T2s and T1, therefore we can find the value for the actual temperature at state 2. Once we substitute and calculate, we are going to get the value for the temperature at state 2A is equal to 856.3 Kelvin. Next, for the state 3, also this information has been given from this question, which is 700 degrees Celsius, and when we convert into Kelvin, we are going to get the value of 973 Kelvin. In order for us to find the temperature at state 4, we are going to use the isentropic relation between the temperature and pressure, and we are going to get the values for the T4 is equal to 338.5 Kelvin. And now we are going to solve the power net out for this simple Brayton cycle. Note that the power in, we are going to use the actual temperature for state 2. Thus, we can get the value of the power net out is equal to 286.2 kilowatt.